Imagine your office network traffic is like cars on a busy highway. Sometimes a single lane isn't enough to handle the volume of data, leading to congestion. A link aggregation group, or LAG, is like adding extra lanes to that highway. By combining multiple physical cables into one logical connection, you allow more data to flow smoothly. A dynamic lag, which uses the Link Aggregation Control Protocol, or LACP, is even smarter. It lets your switches talk to each other and manage those extra lanes automatically. In this episode of Cisco Tech Talk, I'll show you how to set up dynamic lags on your Catalyst 1200, 1300, or 1300X series switch. Next. When configuring dynamic lags, there are some best practices to ensure your network stays stable. Verify that both devices support link aggregation. Ensure the port speed duplex mode, flow control, and MTU size settings are identical on both switches. Configure the lag before adding it to a VLAN. Avoid connecting multiple cables before the lag is configured to prevent network loops, which can slow down or stop traffic. And if the switch detects a mismatch in settings like speed or duplex, it will reject the lag setup. Matching configurations are needed on both switch 1 and switch 2. Start by navigating to the Port Management menu. Under the Link Aggregation section, select Lag Management. For the load balance algorithm, I'll choose IP or MAC address. When you select this, the switch performs load balancing based on IP addresses for IP packet and MAC addresses for non-IP packets. This is a very efficient way to distribute traffic. Next, I'll select the LAG1 interface and click the Edit button. In the name field, I'll enter LAG1. Because I am configuring dynamic lag, I'll enable the Link Aggregation Control Protocol. Now select the members of the lag. I select ports 9 and 10, as these are the two ports I'm connecting between the switches. Once done, click Apply. Now move to switch 2 and repeat the process. Choose the IP or MAC address load balance algorithm. I'll select the LAG1 interface and name it LAG1. Then I'll enable Link Aggregation Control Protocol and select ports 9 and 10 as members. Click Apply. A success notification should show. Great! You can now close the window. You will notice that the link status initially shows as down and the members show as standby. This is normal until the cables are physically connected. Once the cables are connected, the link will show as up, and ports 9 and 10 will show as active members on both switches. To verify the configuration on switch 2, use the command Show Interfaces Port Channel 1. This confirms that the load balancing is set to source destination, MAC, and IP, and that these active interfaces are ports 9 and 10. Since the LACP status is enabled, you know this is a dynamic lag. Finally, click the red blinking floppy disk on both switches to save your configuration. Once LACP is formed, you can manage your VLAN settings for this connection. Navigate to Port VLAN Membership under the VLAN Management section. Select the LAGCP1 interface to see the operational VLAN. By default, it is set to 1. If you need to change this for management or other purposes, select the LAGCP1 interface. Click on Join VLAN and apply the VLAN you need. For example, if you want to configure this for VLAN 10, enter that value and click Apply. Always configure the same administrative VLAN on both switches. If you do not, you will trigger a VLAN mismatch error. After applying these changes, click the blinking floppy disk icon to save your work. That's it! You have successfully configured dynamic link aggregation. This will provide a more reliable and faster connection for your business network. Thanks for watching. I'll see you next time.